Okay, let's try a real example now with our isentropic relations. So I have a Boeing 747 flying at a standard altitude of 36,000 feet. As a note, if you've seen a problem that says standard altitude, that's saying go to the tables in the back of your textbook and find out what the pressure, density, and stuff is. And it says the pressure at a particular point on the wing, not in front of it, that's where the tables come in, but on the wing is 400 pounds per foot squared. And yes, that means we're in English units. Oh, pain, suffering, I'm so sorry. So assuming isentropic flow over the wing, calculate the temperature at this point. So we had the isentropic relation from earlier. We're going to use it to find the ratio of temperatures from our standard temperature out here. If we're going to find our ratios, we need to know what our pressure and temperature actually are in front of that airplane. So let's get that stuff from the tables. If I go to Appendix E and I use a height of 36,000 feet, what I find is that my pressure is 476 pounds per foot squared, and my temperature will be 391 degrees Rankine. Rankine, always absolute, otherwise things go horribly wrong. So that was the easiest part. Just look in your textbook, write down the numbers, and you can move on. Now we do the next easiest part. Isentropic processes are super nice. It's just ratio of pressures. So I know a ratio of pressure. What is the ratio? Well, I know the ratio of my pressure on the wing to the pressure in front of the wing, like way off in the distance where it hasn't been affected by the wing yet. And that'll be equal to the ratio of my temperature on the wing to the ratio of the temperature way off in the distance. So I can then rearrange this. As a note, you'll do this rearrangement quite a bit, so you might want to write down this equation to find out what my temperature is on the wing at that particular point where my pressure is 400 pounds per foot squared. If you're wondering, do I have to convert these units for pressure? You don't, because the units are going to cancel because it is a ratio. However, you do still have to use absolute units. So for temperature, has to go to Kelvin. So going through that, we can calculate and say, okay, 391 degrees Rankine times that ratio raised to this power. Remember, gamma is 1.4. And I get that the temperature will be 372 degrees Rankine. That's it. You just plug and chug, and you're done. So hopefully that wasn't too difficult. We will have harder problems, but when it comes to isentropic processes, it's usually just that easy. So thanks for watching. I hope this helps you. Next time we'll do a little bit harder example. Thanks. Bye-bye.